Alrighty, guys. So this is our last lesson of the term. Actually, it's kind of sad. We're winding down to the end here. What we're going to talk about today, though, is centers and triangles. And so, what we're going to be looking at is there's 4 different types of a center in a triangle, and they all have different properties. We're going to talk about a circumcenter, an incenter, a centroid, and an orthocenter. What I'm going to do is I'm doing this all completely on the computer. I'm annotating these notes with Canvas so you can have them, but then I'm also going to go to this GeoGebra tab and actually construct these things and show you some important properties with them. Okay, so again, we have circumcenter, incenter, centroid, and orthocenter. Okay, so we're going to start here with circumcenter. So here's the general picture of what's going to happen. Oh, and let me preface why we're doing this. We're looking over this because, one, it's kind of a fun thing to do. And then what I want you to be able to do is, up here on this homework page, you're going to have to look at these markings and figure out what the center is that's in the middle of the triangle. Okay? So that's the whole purpose of what we're doing today. So a circumcenter. So the circumcenter here would be the M. It's in the middle. And notice that coming from the M are these little segments. Notice that they're perpendicular to the sides, meaning that when they meet the side, they make a 90-degree angle. And then when they touch the opposite the side, it cuts it in half. Notice how AZ is congruent to CZ. So that means that when M to Z comes down, it makes a 90-degree angle, and it cuts the side in half. And it does that for this side and this side. So the question is, what are these little pieces that are forming M? Well, those are actually, if I can type, those are perpendicular bisectors. And if you think about, we haven't really talked about these all that much, but if you think about what those words mean, it kind of makes sense. Perpendicular means 2 segments make a 90-degree angle, so that's right here. And then we know that bisector means it cuts it in half. So this portion M to Z is a perpendicular bisector because it cuts the side in half and it makes a 90-degree angle. Now, important facts about this. The circumcenter is equidistant from each angle in the triangle. Okay, so this point M is the same distance from angle A, angle B, and angle C. Okay, so you could say AM is congruent to BM is congruent to CM, if you wanted to put that. Okay. Now here's what I like about circumcenters. It allows us to draw a circle around the triangle. Okay, so now I'm going to switch over to the GeoGebra site and show you that. So I'm going to make just a generic triangle. Okay, and I'm going to construct the circumcenter of this triangle. So I'm going to create the perpendicular bisector for every side. So on my GeoGebra site right here is a perpendicular bisector. So I'm going to make it for that side, make it for this side, and then make it for this one. So notice that all 3 of those perpendicular bisectors meet right here at this point that I'm going to point out and call it D. Okay? And I realize that, let me do it this way. Let's put a point here, here, No. Well, anyway, never mind. Sorry, I forgot where I wanted my points to go. I wanted them there, there, and there. Then I'm going to construct segments in here. Okay, now I'm going to see if I can delete some of this stuff so it's not so chaotic. Nope, that didn't work. Okay, I know it's kind of hard to see, but try to ignore this extra stuff outside the triangle. Forgot the word. So what we have here is, this is a piece of the bisector. They just show you enough that goes to the M. Here on my picture, it actually has the entire perpendicular bisector. Anyway, and then we know that this length, and this length are the same. Now I'm going to get rid of some of that stuff. Now I want to show you why the circumcenter is important. If I draw a circle from this center to the edge of the triangle, to the vertex of the triangle, watch. So the circumcenter allows me to construct a circle around the triangle. So we say that we have circumscribed the triangle, meaning it's a circle around the triangle. Okay? So that's just the fancy part of it. So let me get rid of what I had there. Okay, I'll come back to this triangle in a minute. So what you need to look for here is perpendicular bisectors. So you need to check that when these little pieces meet the side, that it's perpendicular and it cuts it in half. That's the key you need to look for there. All right? All right, incenter. That is created by angle bisectors. Okay, so now we've actually cut the angles in half and drawn them out until they've met in the middle of the triangle. So those are angle bisectors. And what's cool is the incenter is equidistant from each side of the triangle. So this center in the middle is equidistant from every side. So this distance xm, ym, and zm, those are all the same. They'll be the same length. And then what's cool about an incenter is that it lets you draw a circle inside the triangle. That's what incenter means. It's to make a circle inside the triangle. Okay, so let's go construct one of these. So here's my triangle. I'm going to construct the angle bisectors. So boom, 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 and then go all the way that way, and then that way. Okay. So I made the angle bisectors for all the angles, and I know there's extra stuff outside the triangle. It's kind of hard to avoid with this program, but it's all right. And so remember that the distance from this center to the edge of the triangle is going to be the same length. So I'm actually going to put a point there. So this distance D to E is actually going to be the radius of a circle. So I'm going to draw my circle. Oops. It's a little off. Let's try it again. Whoops, that's bad. Let's try it again. Well, phooey. Try it this way. There we go. That's a little bit better. So you see how the circle is inside the triangle now. This is called we've inscribed the circle. The circle is inscribed within the triangle. It's inside. All right, get rid of this. Back to our triangle. Whoa, sorry. Okay. Next one is a centroid. So this is created by a median, by medians. What's a median? I've never heard of that. So down here we say a median is created by a vertex, vertex being one of these angles on the triangle. A median is created by a vertex connected to the midpoint of the opposite side. Okay? So to make a median, you first need to construct the midpoints of all the sides. And when you do that, it cuts the sides in half. See how they're cut in half? And then a median comes from the vertex all the way down to the median. Vertex all the way to the median. Or midpoint. Vertex all the way to the midpoint. Okay? It's sort of similar to the circumcenter in that the sides are cut in half. But notice how on circumcenter, the perpendicular bisectors don't go to the vertex. They just go through the triangle. On this one, your medians go from the vertex to the midpoint. Okay? So first thing I'm going to do is construct my midpoints on these sides. Now I'm going to connect the midpoint to this vertex opposite. Midpoint, vertex opposite, midpoint, vertex opposite. So right there, that point that I have labeled G, that is my centroid. And these segments going through the triangle are the medians. Now, what I think is really cool about a median or a centroid is that if you were able to cut this triangle out on paper, and you can balance the triangle on the tip of your pencil. That point G is actually the center of gravity of the triangle. So if you were actually physically able to cut that out, you could balance that triangle on the edge of on the end of your pencil. And of course, if we were in person, I would actually have you try and do that, but alas, we're not. All right, so that is medians and centroids. So let me back out of everything I did here. The last one is the orthocenter. Now, there's not really anything spectacular about the orthocenter. It's just something that happens. But I still want you to be able to identify it. So, orthocenter is created by altitudes. Oops, I can't spell. Now, what's an altitude? Well, we'll come down here and talk about it. So, an altitude is created by a vertex connected to the opposite side so that it is makes a 90-degree angle, so that is perpendicular. So all you do is go from the vertex straight down to the opposite side. Just straight down, make your 90-degree angle. From the vertex, opposite, straight down. Vertex, straight down. Okay? Let's go look at that. So to make my orthocenter, I'm going to click on this perpendicular line option, and I want it to go through this point and this side. So down here is where it meets, and that angle right there will be 90. And if I do this vertex with this side, and then this vertex and this side. So put my point back. That point labeled D is my orthocenter. Okay. All right. So that's all the sides. Centers. Circumcenter, incenter, centroid, and orthocenter. And the whole point of this is you need to be able to look at these markings and figure out which one of these centers it is. So let me show you I'll try and find one of each, all right? So let's start here with the first one. So I'm going to investigate this triangle. Notice that from the middle and you travel to the angles, you see those little arches. So there's one little arc here, two little arches here, three little arches here. That means that those angles have been cut in half. So those angles have been bisected. So which one of our centers was about angle bisectors? Well, if we go back and look what I wrote, it's the incenter. So this first one is an incenter. That's all you do. You just look at the markings and tell me the name. Let's look at this one. So I see perpendiculars on the sides, so I'm going to go back and look at my notes. The only ones that have perpendiculars are the circumcenter and the orthocenter. So how do you tell them apart? Well, circumcenter is made with perpendicular bisectors. So we've got the perpendicular part, but is the side bisected? So let's go back and look. Are my sides bisected? Do you see little tick marks? No, we don't. So that's your clue that this is an orthocenter. Okay? And it's an orthocenter. It comes from the vertex straight down to the side. Vertex straight to the side. Vertex, vertex straight to the side. Okay? Let's look at this one. So I'm looking at the markings. I'm noticing that the sides are cut in half. So looking at this, the only ones that have sides cut in half are circumcenter and centroid. But notice that the circumcenter, when it touches the side, it has to be perpendicular. I need to see these 90-degree angle boxes. So we'll go back and look. I have no 90-degree boxes. So this has to be a centroid. You can also tell that because it comes from the vertex to the middle, and there's no 90. Okay? So now look at this one. I see 90-degree boxes, and my sides are cut in half. So this is a circumcenter because there's 90-degree boxes, and we've cut it in half, the sides. And that's all you do. You just look at the markings and go through the process of elimination. All right? So I did the first 4. The last 6 are for you. And as always, if you have questions, let me know.